All right, number 11, Paul's bicycle shop, 40 bikes are inspected. 19 need new tires, 34 needed gears. We want to use this information to answer the question. So we have three parts. A, what is the greatest number of bikes that could need both? Okay, so you got to kind of play with some scenarios here. So we could have the case to where some of them that needed new tires also needed gears. Has to be some overlap, definitely. It is possible, since the number of people that needed tires is smaller, less than the people that needed gears, it is possible for this diagram to look like this. Maybe 34 needed gears, and all the ones that needed tires, they needed gears as well. It's possible for all of them to be there. So that means that could be 19 here, and then 19 from 34 will give us 15. Okay, it is possible that it could look like this, or some combination, anywhere in between. So the question A is asking, what's the greatest number that could need both? It would be 19. Like all 19 that need tires could be in that group that need gears. And then we might have had, if this was the case, 6 of them might have been okay. That might have been in good shape. So again, that's because 19 is smaller than the 34. All 19 of these could have needed gear repair as well as tires. So I'm going to say 19. B says, what is the least numbers of bikes that could have needed both? So now we're looking at this scenario. So we're going to say if everything only needed one except there was a few of them, what's the smallest number of bikes that could need both? Okay, so here's how we do that. We add them up separately. Well, let's just do it like this. The formula for union, so if I want to add these up together and say that this is going to equal all 40 bikes, it would be those who need tire repair, union or plus those who need gear repair, okay, and we would take away the overlap, the tire and the gear repair, and that should give us our total, which is 40. So we're going to just do some math. We're going to add these up, and then we'll subtract, and it'll tell us what's here. So tires were 19, gears were 34. This is an unknown. I don't know what this is. Minus the overlap equals 40. This will give us 53. Minus some unknown overlap equals 40. And then if we subtract 53 from both sides, this will give us negative x equals negative 13, or furthermore, x equals 13. Okay, so that means 13 of these guys have been double counted. So it's possible that 13 could go there. 13 of them minimum. If that's the case, out of the 19, that means there are 6 left here, because 6 plus 13 will give you 19 tire repairs. And out of 34, you subtract 13 from that as well. That will leave you with 21. So then you can check if we add up 21 and 13 and 6, do we get 40? 6, 1, and 3 is 10. Carry your 1, and we do get 40. So you can see this is the union formula. I didn't write it out as neat as I should, but you just add up what you have, subtract the total, and that'll tell you the overage, which is 13. So at minimum, there's 13. And now we want to know what is the greatest number of bikes that could have needed neither repair. So that's kind of like this diagram. So if all of them needed tire and gear, everybody that needed tire also needed gear, that would leave us with 6 bikes in good shape. If this were the case, that means no bikes were in good shape. All bikes needed something. Some needed both. So the greatest number of bikes that could have needed neither, this case right here would be 6. And if you add these up, that will give us our 40.